The McDonnell Douglas F-15 Eagle is an American twin-engine, all-weather tactical fighter aircraft designed by McDonnell Douglas to gain and maintain air supremacy in aerial combat. Following reviews of proposals, the United States Air Force selected McDonnell Douglas's design in 1967 to meet the service's need for a dedicated air superiority fighter. The Eagle first flew in July 1972, and entered service in 1976. It is among the most successful modern fighters, with over 100 victories and no losses in aerial combat, with the majority of the kills scored by the Israel Air Force. The Eagle has been exported to Israel, Japan, and Saudi Arabia. The F-15 was originally envisioned as a pure air superiority aircraft. Its design included a secondary ground attack capability that was largely unused. The aircraft design proved flexible enough that an all-weather strike derivative, the F-15E Strike Eagle, was later developed and entered service in 1989. The F-15 Eagle is expected to be in service with the U.S. Air Force past 2025. Newer models are still being produced for foreign users. The F-15 production line is set to end in 2019, 47 years after the type's first flight. Development origins. The F-15 can ultimately trace its origins to the Vietnam War, when the U.S. Air Force and the U.S. Navy fought over tactical aircraft being used in the war. At the time, Defense Secretary Robert McNamara was pressing for both services to use as many common aircraft as possible, even if there were performance sacrifices involved. As part of this policy, the USAF and Navy were involved in the TFX program, aiming to deliver a medium-range interdiction aircraft in Air Force use that would also serve as a long-range interceptor aircraft for the Navy. In January 1965, Secretary McNamara asked the Air Force to consider a new low-cost tactical fighter designed for short-range roles and close air support to replace several types like the F-100 Super Sabre and various light bombers then in service. Two basic designs could fill this role. The Navy favored designs like the Douglas A-4 Skyhawk and LTV A-7 Corsair II pure attack aircraft, while the Air Force was more interested in fighter bombers like the Northrop F-5 fighters with a secondary attack capability. The former were more capable in the tactical role, while the latter might be lesser but could defend themselves. If the Air Force did choose an attack design, maintaining air superiority would be a top priority. The next month, a report on light tactical aircraft suggested the Air Force purchase the F-5 or A-7, and consider a new higher-performance aircraft to ensure its air superiority. This point was driven home after the loss of two Republic F-105 Thunder Chief aircraft to obsolete MiG-15s and MiG-17s on 4 April 1965. In April 1965, Harold Brown, at the time director of the DDR and AMP-E, stated the favored position was to consider the F-5 and begin studies of the FX. These early studies envisioned a production run of 800 to 1,000 aircraft, and stressed maneuverability over speed. It also stated that the aircraft would not be considered without some level of ground attack capability. On the 1st of August, Gabriel de Sosway took command of Tactical Air Command and reiterated calls for the FX, but lowered the required performance from Mach 3 to 2.5 to lower costs. Ultimately, the Air Force chose the A-7 over the F-5 for the support role on 5 November 1965, giving further impetus for an air superiority design as the A-7 lacked any credible air-to-air capability. An official requirements document was finalized in October, and sent out as a request for proposals to 13 companies on 8 December 1965. 8 companies responded with proposals. Following a downselect, 4 companies were asked to provide further developments. In total, they developed some 500 design concepts. Typical designs featured variable sweep wings, weighed over 60,000 pounds, included a top speed of Mach 2.7 and a thrust-to-weight ratio of 0.75. When the proposals were studied in July 1966, the aircraft were roughly the size and weight of the TFX, and like that aircraft, a design that could not be considered an air superiority fighter. Smaller, lighter. Through this period, studies of combat over Vietnam were producing worrying results. Previous doctrine had stressed long-range combat using missiles, and optimized aircraft for this role. The result was highly loaded aircraft with large radars and excellent speed, but limited maneuverability and often lacking a gun. The canonical example was the McDonnell Douglas F-15 Phantom II, used by the USAF, U.S. Navy and U.S. Marine Corps to provide air superiority over Vietnam, the only fighter with enough power, range, and maneuverability to be given the primary task of dealing with the threat of Soviet fighters while flying with visual engagement rules. In practice, both due to policy and practical reasons, aircraft were closing to visual range and maneuvering, placing the larger U.S. aircraft at a disadvantage to the much less expensive day fighters like the MiG-21. Moreover, missiles proved to be much less reliable than predicted, especially in close-range combat. Although improved training and the introduction of the M61 Vulcan cannon did much to address the disparity, these early outcomes led to considerable re-evaluation of the 1963 Project Forecast doctrine. This led to John Boyd's energy maneuverability theory, which stressed that extra power and maneuverability were key aspects of a successful fighter design, and these were more important than outright speed. Through tireless championing of the concepts, and good timing with the failure of the initial FX project, the fighter mafia pressed for a lightweight A fighter that could be built and operated in large numbers in order to ensure air superiority. In early 1967, they proposed that the ideal design had a thrust-to-weight ratio of near 1:1, a maximum speed further reduced to Mach 2.3, a weight of 40,000 pounds and a wing loading of 80 pounds-feet squared. By this time, the Navy had decided the F-111 would not meet the requirements, and began development of a new dedicated fighter design, the VFAX program. In May 1966, McNamara again asked the forces to study the designs and see if the VFAX would meet the Air Force's FX needs. The resulting studies took 18 months, and concluded that the desired features were too different. The Navy stressed loiter time and mission flexibility, while the Air Force was now looking primarily for maneuverability. Focus on air superiority. In 1967, the Soviet Union revealed the MiG-25 Foxbat at the Domodedovo airfield near Moscow. The MiG-25 was designed as a high-speed, high-altitude interceptor aircraft, and made many performance trade-offs to excel in this role. Among these was the requirement for very high speed, over Mach 2.8, which demanded the use of stainless steel instead of aluminum in many locations on the aircraft. The added weight demanded a much larger wing to allow the aircraft to operate at the required high altitudes. However, to observers, it appeared outwardly similar to the very large FX studies, an aircraft with high speed and a large wing offering high maneuverability, leading to serious concerns throughout the Department of Defense and the various arms that the U.S. was being outclassed. The MiG-23 was likewise a subject of concern, and it was generally believed to be a better aircraft than the F-4. the FX would outclass the MiG-23, but now it appeared that the MiG-25 would be superior in speed, ceiling and endurance to all existing U.S. fighters, even the FX. Thus, an effort to improve the FX followed. Both Headquarters USAF and the TAC continued to call for a multi-purpose aircraft, while both DeSosway and Air Chief of Staff Bruce K. Holloway pressed for a pure air superiority design that would be able to meet the expected performance of the MiG-25. During the same period, the Navy had ended its VFAX program and instead accepted a proposal from Grumman Aircraft for a smaller and more maneuverable design known as VFX, later becoming the F-14. VFX was considerably closer to the evolving FX requirements. The Air Force infighting was eventually ended by the worry that the Navy's VFAX would be forced on them. In May 1968 it was stated that "we finally decided, and I hope there is no one who still disagrees, that this aircraft is going to be an air superiority fighter." In September 1968, a request for proposals was released to major aerospace companies. These requirements called for single-seat fighter having a maximum takeoff weight of 40,000 pounds for the air-to-air role with a maximum speed of Mach 2.5 and a thrust-to-weight ratio of nearly 1:1 at mission weight. It also called for a twin-engine arrangement, as it was believed this would respond to throttle changes more rapidly, and might offer commonality with the Navy's VFX program. However, details of the avionics were left largely undefined, as it was not clear whether to build a larger aircraft with a powerful radar that could detect the enemy at longer ranges, or alternately a smaller aircraft that would make it more difficult for the enemy to detect it. 4 companies submitted proposals, with the Air Force eliminating General Dynamics and awarding contracts to Fairchild Republic, North American Rockwell, and McDonnell Douglas for the definition phase in December 1968. The companies submitted technical proposals by June 1969. The Air Force announced the selection of McDonnell Douglas on the 23rd of December 1969. The winning design resembled the twin-tailed F-14, but with fixed wings. Both designs were based on configurations studied in wind tunnel testing by NASA. The Eagle's initial versions were the F-15 single-seat variant and TF-15 twin-seat variant. These versions would be powered by new Pratt & Whitney F-100 engines to achieve a combat thrust-to-weight ratio in excess of 1:1. A proposed 25 mm Ford Philco GAU-7 cannon with caseless ammunition suffered development problems. It was dropped in favor of the standard M61 Vulcan gun. The F-15 used conformal carriage of 4 Sparrow missiles like the Phantom. The fixed wing was put onto a flat, wide fuselage that also provided an effective lifting surface. The first F-15A flight was made on the 27th of July 1972, with the first flight of the 2-seat F-15B following in July 1973. The F-15 has a look-down, shoot-down radar that can distinguish low-flying moving targets from ground clutter. The F-15 would use computer technology with new controls and displays to lower pilot workload and require only one pilot to save weight. Unlike the F-14 or F-4, the F-15 has only a single canopy frame with clear vision forward. The USAF introduced the F-15 as the first dedicated USAF air superiority fighter since the North American F-86 Sabre. The F-15 was favored by customers such as the Israel and Japan arms. Criticism from the fighter mafia that the F-15 was too large to be a dedicated dogfighter and too expensive to procure in large numbers led to the lightweight fighter program, which led to the USAF General Dynamics F-16 Fighting Falcon and the middleweight Navy McDonnell Douglas F-18 Hornet. Further development: the single-seat F-15C and two-seat F-15D models entered production in 1978 and conducted the first flights in February and June of that year. These models were fitted with the production Eagle package, which included 2,000 pounds of additional internal fuel, provisions for exterior conformal fuel tanks, and an increased maximum takeoff weight of up to 68,000 pounds. The increased takeoff weight allows internal fuel, a full weapons load, conformal fuel tanks, and 3 external fuel tanks to be carried. The APG-63 radar uses a programmable signal processor, enabling the radar to be reprogrammable for additional purposes such as the addition of new armaments and equipment. The PSP was the first of its kind in the world, and the upgraded APG-63 radar was the first radar to use it. Other improvements included strengthened landing gear, a new digital central computer, and an overload warning system, which allows the pilot to fly up to 9 grams at all weights. The F-15 multi-stage improvement program was initiated in February 1983 with the first production MSIP F-15C produced in 1985. Improvements included an upgraded central computer, a programmable armament control set, allowing for advanced versions of the AIM-7, AIM-9, and AIM-120A missiles, and an expanded tactical electronic warfare system that provides improvements to the ALR-56C radar warning receiver and ALQ-135 countermeasure set. The final 43 F-15Cs included the Hughes APG-70 radar developed for the F-15E. These are sometimes referred as enhanced Eagles. Earlier MSIP F-15Cs with the APG-63 were upgraded to the APG-631 to improve maintainability and to perform similar to the APG-70. Existing F-15s were retrofitted with these improvements. In 1979, McDonnell Douglas and F-15 radar manufacturer Hughes teamed to privately develop a strike fighter version of the F-15. This version competed in the Air Force's dual-role fighter competition starting in 1982. The Boeing F-15E strike variant was selected for production over General Dynamics' competing F-16XL in 1984. Beginning in 1985, F-15C and D models were equipped with the improved P&AMP WF-100PW220 engine and digital engine controls, providing quicker throttle response, reduced wear, and lower fuel consumption. Starting in 1997, original F-100PW100 engines were upgraded to a similar configuration with the designation F-100PW220E starting. Beginning in 2007, 178 USAF F-15Cs were retrofitted with the APG-633 active electronically scanned array radar. A significant number of F-15s to be equipped with a joint helmet-mounted cueing system. Lockheed Martin is working on an IRSD system for the F-15C. A follow-on upgrade called the Eagle Passive Active warning survivability system was planned but remained unfunded. Boeing was selected in October 2015 to serve as prime contractor for the EPAWSS, with BAE Systems selected as subcontractor. The EPAWSS is an all-digital system with advanced electronic countermeasures, radar warning, and increased chaff and flare capabilities in a smaller footprint than the 1980s-era tactical electronic warfare system. More than 400 F-15Cs and F-15s will have the system installed. In September 2015, Boeing unveiled its 2040 Eagle upgrade, designed to keep the F-15 relevant through 2040. Seen as a necessity because of the low numbers of F-22s procured, the upgrade builds upon the company's F-15SE Silent Eagle concept with low observable features. Most improvements focus on lethality, including quad-pack munitions racks to double its missile load to 16, conformal fuel tanks for extended range, Talon Height communications pod to communicate with fifth-generation fighters, the APG-633 ASA radar, a long-range infrared search and track sensor, and BAE Systems Eagle passive-active warning survivability systems. Design overview: the F-15 has an all-metal semi-monocoque fuselage with a large cantilever shoulder-mounted wing. The wing platform of the F-15 suggests a modified cropped delta shape with a leading-edge sweep-back angle of 45 degrees. Ailerons and a simple high-lift flap are located on the trailing edge. No leading-edge maneuvering flaps are utilized. This complication was avoided by the combination of low wing loading and fixed leading-edge camber that varies with span-wise position along the wing. Airfoil thickness ratios vary from 6% at the root to 3% at the tip. The empennage is metal and composite construction, with twin aluminium composite material honeycomb structure. Vertical stabilizers with boron composite skin, resulting in an exceptionally thin tailplane and rudders. Composite horizontal all-moving tails outboard of the vertical stabilizers move independently to provide roll control in some flight regimes. The F-15 has a spine-mounted air brake and retractable tricycle landing gear. It is powered by two Pratt & Whitney F-100 axial compressor turbofan engines with afterburners mounted side by side in the fuselage, fed by intake ramps. The cockpit is mounted high in the forward fuselage with a one-piece windscreen and large canopy for increased visibility and a 360-degree field of view for the pilot. The airframe began to incorporate advanced superplastically formed titanium components in the 1980s. The F-15's maneuverability is derived from low wing loading with a high thrust-to-weight ratio, enabling the aircraft to turn tightly without losing airspeed. The F-15 can climb to 30,000 feet in around 60 seconds. The thrust output of the dual engines is greater than the aircraft's combat weight, so it has the ability to accelerate vertically. The weapons and flight control systems are designed so that one person can safely and effectively perform air-to-air combat. The A and C models are single-seat variants. These were the main air superiority versions produced. B and D models add a second seat behind the pilot for training. E models used the second seat for a weapon systems officer. Visibly, the F-15 has a unique feature vis-a-vis other modern fighter aircraft. It does not have the distinctive turkey feather aerodynamic exhaust petals covering its engine nozzles. This is because the petal design on the F-15 was problematic and could fall off in flight, therefore they were removed. resulting in a 3% aerodynamic drag increase. Avionics. A multi-mission avionics system includes a heads-up display, advanced radar, an ASN-109 inertial guidance system, flight instruments, ultra-high-frequency communications, and tactical air navigation system and instrument landing system receivers. It also has an internally mounted tactical electronic warfare system, identification friend-or-foe system, electronic countermeasures suite, and a central digital computer. The head-up display projects, through a combiner, all essential flight information gathered by the integrated avionics system. This display, visible in any light condition, provides the pilot information necessary to track and destroy an enemy aircraft without having to look down at cockpit instruments. The F-15's versatile APG-63 and 70-pulse Doppler radar systems can look up at high-flying targets and look down, shoot down at low-flying targets, without being confused by ground clutter. These radars can detect and track aircraft and small high-speed targets at distances beyond visual range down to close range, and at altitudes down to treetop level. The APG-63 has a basic range of 100 miles. The radar feeds target information into the central computer for effective weapons delivery. For close-in dogfights, the radar automatically acquires enemy aircraft, and this information is projected on the head-up display. The F-15's electronic warfare system provides both threat warning and automatic countermeasures against selected threats. Weaponry and external stores. A variety of air-to-air weaponry can be carried by the F-15. An automated weapon system enables the pilot to release weapons effectively and safely, using the head-up display and the avionics and weapons controls located on the engine. Throttles a control stick. When the pilot changes from one weapon system to another, visual guidance for the required weapon automatically appears on the head-up display. The Eagle can be armed with combinations of 4 different air-to-air weapons: AIM-7F, Sparrow missiles, or AIM-120 AMRAAM advanced medium-range air-to-air missiles on its lower fuselage corners, AIM-9L Sidewinder, or AIM-120 AMRAAM missiles on 2 pylons under the wings, and an internal 20mm M61 Vulcan Gatling gun in the right-wing root. Low-drag conformal fuel tanks were developed for the F-15C and D models. They can be attached to the sides of the engine air intakes under each wing and are designed to the same load factors and airspeed limits as the basic aircraft. They degrade performance by increasing drag and cannot be jettisoned in flight. Each conformal fuel tank can hold 750 U.S. gallons of fuel. These tanks increase range and reduce the need for in-flight refueling. All external stations for munitions remain available with the tanks in use. Moreover, Sparrow or AMRAAM missiles can be attached to the corners of the conformal fuel tanks. The 57th is based at Keflavik, Iceland, was the only C-model squadron to use CFDs on a regular basis due to its extended operations over the North Atlantic. With the closure of the 57th, the F-15 is the only variant to carry them on a routine basis. CFDs have also been sold to Israel and Saudi Arabia. Upgrades. The McDonnell Douglas F-15 Strike Eagle is a 2-seat, dual-role, totally integrated fighter for all-weather, air-to-air and deep interdiction missions. The rear cockpit is upgraded to include 4 multi-purpose cathode ray tube displays for aircraft systems and weapons management. The digital, triple redundant Lear Siegel aircraft flight control system permits coupled automatic terrain following, enhanced by a ring laser gyro inertial navigation system, for low-altitude, high-speed penetration and precision attack on tactical targets at night or in adverse weather. The F-15E carries a high-resolution APG-70 radar and LANTIRN pods to provide thermography. The APG-632 active electronically scanned array radar has been retrofitted to 18 new Air Force F-15C aircraft. This upgrade includes most of the new hardware from the APG-631, but adds an AESA to provide increased pilot situation awareness. The AESA radar has an exceptionally agile beam, providing nearly instantaneous track updates and enhanced multi-target tracking capability. The APG-632 is compatible with current F-15C weapon loads and enables pilots to take full advantage of AIM 120 AMRAAM capabilities, simultaneously guiding multiple missiles to several targets widely spaced in azimuth, elevation, or range.